So chapter 5, the very beginning of chapter 5 talks about, I believe it was like frequency tables and things of that nature. It's really about, all of chapter 5 is about probability. You're going to need to know or be able to reference, know the definitions. And I mean, I know this is multiple choice or fill in the blank type questions, but I would know the definitions by being able to explain them, right? You know, in that last test, I did a lot of that where, hey, explain a probability experiment, explain sample space. So yeah, I know you can just kind of give me the definition, but I'm looking for it with an example, okay? When I say explain to get full credit, I want you to put an example. And you'll see the first, first few pages are purely about, probability model, the event, really defining probability, or computing probabilities with equal outcomes, things of that nature. Defining what an unusual event is. Yeah, I'm not worried too much about section 5.1, but I'll tell you some homework that's good to look at. I would mainly know the definitions because that section kind of lays the foundation with their definitions there for all of chapter 5. But in 5.1 for the homework, some that I like. I mean, just really some basic stuff. Like 13 through 18. Those are good, where it gives you an event and then, or an experiment actually, and then it asks you about outcomes from the experiment. Okay, there we go. And then, ooh, excuse me. Yeah, and then one I'll choose some odd ones because I know you guys have the answers. But let's say something kind of basic but real world, like 29 and like 41, something like that. So 5.1, I would kind of know how to do those. And look, now this stuff here, if you've done the homework as you've gone along, this stuff will be real basic. But no, it was kind of laying the groundwork for the stuff at the beginning of the chapter. So 5.2 brought in the addition rule and the complement rule. So I would look at, this is just like if you're, adding and subtracting, the general addition rule, which is on page 218, you're going to need to know that. And for an example, I would look at number 1 on page 218. Excuse me. Hold on. Let's get to the actual homework. And then some kind of basic ones like 13, where I give it to you very straightforward. And then finding the complement, I'll do like a real basic one, like 19. Then hold on. Nope, I don't like those. Hold on, let me find a good one. I remember there was one in the section that I liked. Oh, like 37. It's kind of just a good, easy, kind of basic rule of complements. And then ooh, okay, I know that it's not odd, but I like the way 40 is set up. Oh, which is a lot like 39. So you kind of mark through that. So 39. But if you want to look at 40 as well to kind of test out your knowledge, those are good for like kind of real world complement and not complement, but the addition rule. And then let's look at 5.3. Yeah, which we get into conditional probability in the multiplication rule. Yeah, number 1 again was a good one. Number 2, those are just kind of good basic conditional probability and multiplication rules. And then using the like equation 15, 21. I'll tell you, to really grasp mutually exclusive, what that means, I'm not going to put this in the homework per se, but 27 through 31 there, that really kind of goes over it in a nice like explanation way. So if you weren't really totally grasping mutually exclusive events, that's a good way to look at it and grasp it. I like 35. Guys, there's no way I'm going to ask this many questions on the test, but these are just good overall question concepts. Yeah, 39. And I don't think I could necessarily write it exactly like that. I don't know how to put a table in Blackboard, but that's a good one when it comes to the conditional probability, like a real world conditional probability question. So let's say, okay, let's say 47. That's a good example too for the multiplication rule. And then 51. 5.4. Oh yeah, the counting rules. How could I forget the counting rules? So the counting rules, which really were the permutations and combinations. Hey, Jacob's seen this before. He took my Math for Teachers 3 class. Were you in that class, Jacob? Are you back there?
I didn't have to for mine.
What'd you say?
Hear me?
Yeah.
I didn't have to have mine.
Oh, you didn't? Okay. It's like, you've seen that. It's one of those Math for Teachers 3 concepts. Okay. I thought you were in that class. That's weird. So you need to really understand like when you would use factorial, when you would use permutation, and when you would use combination, because the math isn't hard. Remember, we went over how to do all that in the calculator. So it's not about the math per se that's going to be hard if you know how to put in your calculator. It is when to choose one or the other. Okay, knowing when to choose a factorial, a combination, or a permutation. And so when the homework, I'm going to just give you examples of each, but I'll tell you the math isn't the hard part. It's going to be when to choose one or the other. So if we look at like 29, this is on page 245. 29. Yeah, one that brings in probability with it as well as 33. 35 as well. Those are both 33 and 35 are pretty good for this section, I'll tell you. I like 41 because it's about the lottery, but that's the only reason I'm putting it on there. Okay, and then let me look at, I'll tell you, at the end of the review, at the end of the chapter, your book does a really good summary. And it's on page 247, starts on page 247, and it goes to like page, I think 250. I would look at that. I mean, it's just a good review, 247 to 250, and you'll see it says like chapter 5 summary, and then it goes over a chapter quiz, and you've got the answers for it. And then review exercises. And it's nice because it's kind of set up, it's kind of set up like a test. But I would look at those, and I've looked at those in the past, and I know that they've just been really good examples, and you have the answers to them too, which is nice. And I could see me getting lazy and just stealing some from those sections. Okay, I'm not going to choose the exact same question because you have the answer to it, but maybe change the number up, right? And you'll see when you're doing this homework, it'd be easy. It'd be easy for me to like choose 39, like the same information, but then like ask a different question based on the 39 data, right? I might do that a little bit just because I'll get a little lazy when I'm making this test. So chapter 6 is about discrete. Actually, yeah, it's all about discrete, isn't it, data? Yeah, discrete probability. And then 6.1 really lays out what random variables are. And again, 6.1, like 5.1, is a lot about definitions. Okay, it kind of lays the groundwork with definitions. It does go into finding some, but you need to know the definitions from this section because it lays out chapter 6 with what you do after chapter 6 with 2 and 3, right? It's only 2 and 3. Yeah. Excuse me. The homework, though, from 6.1 that I would look at man, it's just hard. It's hard to, I got to find a way to put some of these like kind of tables in Blackboard. And I know I can, I just have to do it. I have to do some searching. But like number 43, 47, because it gives it 2 different ways. 51 again, because I like the lottery questions. Yeah, and when it goes over expected value, that's the one, and it's in both of those that are actually all 3 that I've asked you, so that's good. The mean or the expected value, they're the same thing. Let's look at 57 as well. I like that one. Talks about a business projection. Now 6.2 is on the binomial distribution, and I'm just going to ask you some straightforward kind of binomial questions. Nothing crazy. I'm not going to make you build models on it or anything like that. It's just you've got to understand. Look, I'm not going to tell you to use the binomial distribution. You have to pull that out from the information that's given. So you remember with binomial distribution, it was about true, false, or right, wrong, or something of that nature. So like 29 is a good kind of basic example. 33, man, they're all good. 39. And I'll tell you, you don't have to worry about me asking about standard deviation or the mean. Well, I might ask you the mean, but don't worry about standard deviation when it comes to 6.2 and 6.3. So 6.3 was on the Poisson distribution. And again, so Poisson, though, it was about the interval or the average with the intervals. And remember, binomial and Poisson are both in your calculator, right? So I'm not necessarily worried about, in the math, how to do it by hand. I really kind of don't expect you to do these by hand. It's if I give you the question, you being able to go, oh, hey, that's a Poisson. Like, for instance, like number 23 on page 285. 23 says the number of tweets received by a certain Twitter user, well, it says is a Poisson variable, but it would be, the way we know that is this person tweets 8 tweets an hour, right? And then what's the probability 5 tweets are received in a given hour? So it's talking about these intervals. So, this person usually does 8 tweets an hour. what's the probability they only do 5, right? That's not like binomial, which is going to be more true false, where like Shaq makes a free throw 52% of the time. What's the probability if he shoots 10 times, he makes 7 free throws, right? That's binomial, where Poisson's going to be about intervals, right? Typically it's time. I mean, for that one, it's time as well, because it's like 8 tweets per hour. But realize it's for Poisson, it's about intervals. So 27, and I'm going to go back. I think we did 20 in the potholes. Yeah, definitely. I remember that one. That's a good one. I know those are out of order, but those are 3 good examples from 6.3. And again, I'm telling the chapter 6 summary for this one's a little shorter. The summary, which starts on page 286, and it goes to 280, really kind of the top of 289. You don't have to worry about the case study or anything like that. But case study is actually kind of interesting. But 286 to 289, that's a good review. So again, if I get a little bored or get a little lazy, which I am definitely known to get a little, we like to call it efficient in mathematics. If I get a little efficient, then I'll probably just steal some from your homework, from the study guide, things of that nature, and